Oh. Yeah, I don't understand why this is not working. Because it should be the exact same matching logic here. Wait. So we have 2 matches. Oh my, how did this work previously with that bug, huh? Just got really lucky, wow. Wow. Oh my goodness. I don't even remember, I skipped past. Wow, just missed out on points for part 1. Well, that's unfortunate. Okay, well, this is a fairly interesting problem. Let me just turn down the music real quick. Okay. This one we'll go through and clean it up. Okay. So, part 1 is about scratch cards, and we have a bunch of these cards. These are the numbers that we have on the right side, and these are the winning numbers on the left side. And what the question asks is, how many points are your cards worth in total? And so what we do is we look at the numbers we have, and if any of them match any number on the left, we basically, the value of the card gets times by 2. So it basically is powers of 2. So if you have 1 matching number, it's worth 1. If you have 2 matching numbers, it's worth 2. If you have 3 matching numbers, it's worth 4, etc. So 1 for the first match, and then double 3 times for each of the 3 matches after the first. Yeah. So pretty straightforward for this. It's just parsing at the start. So for line in file input, first we want to grab the card ID, which I guess doesn't really matter. Going to be int of card. We strip out the first 5 characters here, and then we just grab the ID. So that's that. These variables, I didn't note which was which, but these are the winning numbers and your numbers on each of these sides. So we'll just say winning, and then we parse out the winning numbers like that, and your numbers here are here. We're just taking the string and splitting it and integering them. Great. So we'll do this. Now, so part 1 is asking us, we just want to see what numbers are, we have to basically figure how many matches we have, and then we can reverse engineer how many points we get. So actually, rather than make this a list, we can actually make this into a set to make the lookup a little bit faster. This should work like that. Let's say part 1 is going to be equal to 0. So we have to count how many matches we have. This is part of part 2. So part 1 is it's going to be for n in each of the winning numbers, if n is in, in all of your numbers, if n is in the winning numbers, we'll go matches gets incremented like that. And then the answer to part 1, we just accumulate, it's 1 if we get 1 match, 2 if we get 2 matches, etc. So if we get 0 matches, it should be 0. If we get 1 match, it should be 1. So basically, if matches is greater than 0, it's going to be equal to 2 to the power of the number of matches minus 1, I think is how the math works here. Right, because if we have 1 match, it's going to be 2 to the power of 0, which is 1. Let's just validate that that's correct. So, print part 1 should be equal to this, and then if we run it, day 4, and we pass it the inputs, like that. Of course we're wrong. Oh, equals. Plus equals. We get 21158. Great. So for part 2, it's a little more interesting of a problem. Basically, rather than just getting points, we go in order and you win sequential versions of the next scratch card that comes. And so if we started with card 1, we match 4 cards, we're going to win 4 remaining scratch cards. We're going to win a 2 card, a 3 card, a 4 card, and a 5 card. Then this is interesting because on card 2 we have 2 matches, but we have an extra copy of it because we won a copy from card 1. So we're going to win a copy of 3 and a copy of 4, but we're going to win 2 copies because our original card wins a 3 and a 4, but then our copy wins a 3 and a 4. So you can see how as you go on, you're going to be getting more and more basically duplicates of your winning cards. So that's where this counter comes into play, but I think default dict might even be better here. So we'll go part 2 cards. We're going to make it a default dict where we initialize the values to 1. So we do that with lambda. I think we just return 1. Should work if I remember correctly. So basically this means if we access a value in here and it doesn't already exist, if the key doesn't exist, it's going to be equal to 1. So this still applies for part 1, but then for part 2 we want to figure out how many matches we have. And somehow, I guess it didn't matter. Oh, the range wasn't part of part 1, that's why. So I wrote a bug here where I was starting at, it should have been from card to card plus matches plus 1 to figure out, we need to figure out which subsequent cards we're going to be winning. So basically for card copy in range, so we're going to start at our current card, the next one, because if we're processing card 1, we're going to win like 2, 3, 4, etc. And how many more cards do we win? We win our current card ID plus 1 plus the number of matches plus 1, right? Here we've matched 4 cards, so we want to iterate over 2, 3, 4, and 5. And what are we doing here? We're adding the number of cards basically to that value. So we're going to say in our part 2 cards for that copy ID, we're going to add not just 1 though, but it's how many cards we're currently iterating over, because we want to make sure that if we've already copied a card, like in this case of the instruction, we're not adding just 1 version of cards 3 and 4, but 2 versions. So we do that like this. We should be able to just access our current card that we're on, like this. And we can kind of demonstrate this working if we, I guess it's kind of annoying because I don't have it reading my pasteboard for the sample inputs, but let's just do this. We'll paste this in, that's fine, and then okay, so now we're, oh, it's not supposed to be that. Do we just do like this? Great. So we'll figure out, we'll print the card ID that we're on, which is card ID. We'll print matches, adding part 2 cards, card ID, copies of, and then the new card that we're copying. So here we're going to add, like the instructions say, 1 copy of cards 2, 3, 4, and 5. Now for card 2, we found 2 matches. We're going to add 2 copies of 3 and 2 copies of 4 because of this copy. Now here we have 4 copies of card 3, so we're going to win 4 copies of 4 and 5, like here, which is exactly what it says. So based on these print statements, we'll just leave them in for a sec. This should be working correctly. And then to recover the final value, we just basically sum up all those values. So it's the sum of part 2 cards dot values. Now this should work correctly. One thing that I want to do just to make sure, we're not guaranteed to ever access card 1 and copy anything over if there's 0 matches, and therefore it won't be initialized in the default dictionary. That key won't exist. So maybe this isn't actually the best way to do it, because there's a chance that we're iterating over all the cards, but no copy of that card gets made, and it also has no matches, so we don't ever see that we have 1 card. So that's interesting. We could just try running this and see what happens. Yeah, so we actually got the wrong value here, probably because of the edge case that I was considering. If we actually run it on the sample here, yeah, we're off by 1. So I think when I was actually solving the problem, I accounted for that by just saying part 2 cards of the card that we're on is just going to be incremented by 1. So if we have 0, then we now have 1. It's like we're creating that copy of that card. So if you run this, this won't work here because this assumes that we'll go back to the original solution. We won't try to be clever and initialize this with a value of 1. We'll just do it like that. So this is worth 13 for part 1, and then for part 2 we get 30 in the sample, and now when we run it on my real input, we get the expected final answer. So yeah, interesting problem. We just missed points on part 1. I'm not exactly sure why. We're just like a little slow, I think, on iterating through things. It could have been faster. Oh, I know. I stumbled on the math for figuring out like to the power of this. I was trying to special case 0 matches into it as well. If there was like a one-line way to do it, and also struggling to do the bit shift operator on the total. So we probably could have scored a few points if we're like slightly faster. We were 251 and the cutoff was like here. Yeah, so if we're a few seconds faster, we would have been somewhere around here. But all in all, pretty good day.